morning and good afternoon, good evening, whatever the time is. Today I'm solving yet another question, but because I am almost running out of time, and I'm feeling very sleepy, I have just pre-written the code and I'm just going to explain what I did. The steps that I took to get to the answer. So the question is, you have been given an array which has already been sorted, right? And they are asking you to find to return the square of that array in sorted order. And so, the example that they gave us was that you've been given minus 9, minus 2, 0, 2, and 3, and you're supposed to return the square of this array, but also in sorted order. So, the sorted order is going to be 0, 4, 4, 9, and 81. Okay, and so how are you going to do this question? So, there are several ways of solving it. So the simpler and much straightforward way is to square everything in the array and then sort the array. But when we do that, the runtime complexity for such a solution is going to be the big O of n log n. And the question that we must ask ourselves is, can we do better? And the answer is yes. We can actually reduce the runtime of this algorithm to linear complexity as in big O of n if we apply this other method, as in we first of all split the array into two parts, like the positive part and the negative part, and then we would find the square of these two separate halves, and after that we will merge these two together, and all of that can happen in linear time complexity. So this solution actually uses that way of solving the question actually. So I began by first getting the length of the original array that was given to us, and then I also wanted to find the count of the negative numbers and the count of the positive numbers actually. And so I needed these things so that I can create an array of that size. And so this is where I got the count for the negative and the positive numbers. I looked through it and I got the count. And after that, I used it to create an array to hold the positive numbers and the negative numbers. And so if you look at it carefully, you will see that for the negative numbers, right? If the square of this guy will be bigger than this guy, like the square of this guy will be bigger than this, and vice versa. So here, what I did was that instead of here was when I was inserting the square of the numbers into the arrays bar. For the negative side, instead of inserting them from the start to the end of the array, I inserted them from the end to the start of the array. Hence, why I'm using this logic here. You see, I said n equal to the negative count that we got here minus 1, as in we are starting from the back of the array and we are moving to the 0th position. But for the positive, this one, it was straightforward, so that I don't need to waste time reversing the array or anything of that nature. And now, once we have gotten the positive square array and the negative square array, we are now going to merge the two array into one. And so to merge them, we will now, I think this, I am not using this one anywhere in the code, I guess, so I can take it up. This one is completely useless. It was an old method that I was trying to experiment with, so I didn't use it. So I start a while loop, and so this index will keep track of the negative square array, and this one will keep track of the positive square array, and this will keep track of the current array of the final answer that we will be returning to the user here. And so we say that okay, we started a while loop and we said while I is less than length and while n is less than the negative count and p is less than the positive count. So you see, I have explained why we are doing this, And so we said okay, so we check. So we check in the array if at the current position of n, so like so in the beginning n will be at 0 and p will also be at 0, so like we are checking each of them their first element. So like we know that like what is in the positive array, the post array is something like I think 0, 4 and 9, and we know that what is in the negative array is also something like let me see, is also 4 and 81. So here we are checking, we are saying that okay, at the 0th position of the positive array and at the 0th position of the negative array, take the two numbers there and compare. So when we compare the smaller one, the smaller of those two, we will put into our answer array at the position I. So right now I is also 0. So when we put in the position I, we will now increase n by 1. So like the one that was smaller will be increased. So like in this case, okay, this one is the previous distance. I changed some few stuff. So in this case, we will pick this one. So like we will increase p by 1, and I will also increase by 1, but n would remain the same. It will be 0. So then we will come again. We will check p 1 to n0, and then we will check 4 4. So like they are the same. So like we will just, according to this algorithm, we will just use p again. So we will just use p again, and then we will get like we will just use p again, and then we will like increase the distance. So like this is just like the merging method, you know, like it's a very simple and self-explanatory distance. And then once we finish the remainder, we will just add it to the distance, since we know that everything is like there's nothing left, and then we can just add it to the answer array straightforward. And so like if we follow these steps, then we can do this we can solve this question in linear complexity. So this, I just wrote it here to check if the answers that I was getting is correct. And so when I entered this one, the answer that I was supposed to get is this, and I indeed get that. I can rerun it again. Yes. So this is to show that yeah, this solution works, and I didn't have to use the sort method, you know, to do it. Yeah. So this is the video for today. Thank you very much, and see you tomorrow.